Hello, this is Tech, 19th of October 2010. Well, here it is. This is the electrolyzer I started to develop just over 2 years ago, to which I made a brief reference in one of my videos on YouTube. The electrolyzer contains 107 stainless steel plates, each one being 0.9 millimeters thick, and each side of each plate is 200 millimeters. A lot of CAE design and development has gone into this project so far, and in fact that is where most of my time has been spent during the last 2 years. The distance between each plate is maintained accurately and very evenly via these precision CNC spacers. Now, I can't stress enough the importance of paying attention to precision during the fabrication of such a device. Now, the electrolyzer has 4 gas output ports, 2 on each side, 2 here and 2 here, taken from the top of the corresponding end plates. It also has 4 electrolyte input ports, once more 2 on each side, this time taken from the lower outer part of each end plate. We see them there. So there's one there and another one there. We also see there the red positive lead going to the variac. On this side we see the remaining input ports down there and the black negative lead going to the variac. I've also placed this tube in such a manner as to expedite the convenient evacuation of electrolyte from the electrolyzer and thus emptying the whole system. I've also allowed for a visual means to indicate the level of electrolyte within the electrolyzer itself, as well as one here to indicate the same thing, but now with regard to the entire system. The gas output of the electrolyzer is fed into these 2 external containers, and the pressure of the gas at the top part of the container, of each container, is maintained at the same pressure because of this tubing here, which also serves as a general gas outlet of the system. Now, the combined effect of the gas pressure and that of gravity and that of an optional pump serves to act on the contained electrolyte in such a manner that it is forced out of this tube here onto this T connection and onto the corresponding electrolyte input port on either side of the electrolyzer. At the moment, the temperature of the electrolyte in these external tubes is shown to be around 152 degrees Fahrenheit. That's interesting because, given that this is primarily an all plastic device apart from the stainless steel plates, there are no signs of any liquid leakage whatsoever, not even the slightest hint of any residual, in fact, anywhere. Now, that electrolyte at the moment is made up of 12 liters of deionized water and 60 grams of sodium hydroxide. I've placed the electrolyzer on these 2x4s in order to provide 2 things. One, should there be any leakage of electrolyte, it should seep into the fibers of the wood and manifest itself as a darkened, damp patch, thus being an easy visual cue that there is electrolyte leakage, which is non-existent at this time. In addition to that, the raising of the electrolyzer from the table serves to introduce this gap here, which runs along the entire length of the electrolyzer, and hopefully that should serve as an aid to keeping it cooler. Now, at the moment the entire system is undergoing testing for pressure, temperature and plate conditioning. With regard to plate conditioning, the amperage is around 3.7, at times 3.8 amps and around 182 volts. The conditioning is driven by this homemade variac because I'm way too cheap to buy a ready-made one. Instead of cut costs By buying the Variac component itself from RS Components. This one's rated at 8 amps. And I've built the casing and constructed the wiring in such a manner as to allow for a variable AC output and a variable rectified DC output and an on-off switch. Now, the primary objective for this project has been to devise a method whereby an electrolyzer can be constructed in such a way that it inherently provides 100% electrical isolation between any pair of stainless steel plates. That is a true 100% electrical isolation, unconditionally. Now, I have not approached it electrically. In other words, I have not tried to seek a solution which is electrical in nature, neither chemical, i.e. by sprays or coating or any fancy treatment of the plates. Neither have I opted for investigating methods of so-called staggering of holes. Instead, I've taken a mechanical approach, because my thinking was, if I was able to devise a method whereby every pair of stainless steel plates is isolated in such a manner that they are airtight, then it should follow that, dependent on choice of materials, electrical isolation should result. And indeed, in this case, that's how it's turned out. In fact, it has turned out so well that I feel that from now on this is the choice of design of electrolyzer from this point onwards for myself. Now, what I haven't told you yet is the operating conditions which I've outlined earlier. These amps, these volts, this power supply. Well, those operating conditions have been in place continuously as part of the plate cleansing process for the last 3 days. Now, bearing in mind those operating conditions and recalling the running temperature we saw earlier, and also recalling the fact that there is no electrolyte leakage, whilst at the same time always maintaining 100% electrical isolation between every pair of plates, I feel that the primary objective overall as a system has been achieved remarkably well, and I'm very, very pleased with this result so far. I will undertake MMW tests at a later date and post them, but at this time they are completely irrelevant because as a system it's undergoing conditioning. I'll also post construction details, that's detailed construction information, for those who wish to replicate the fabrication of this device. In the meantime, I will look forward to any comments you may have, and hope to read of them soon.